Hey everyone, today we're diving into one of the most fundamental concepts in calculus, limits of functions, or simply limits. By the end of this session, you'll understand what a limit really means, how to compute them, their geometric interpretation on graphs, and why they matter so much. Limits are the foundation of everything in calculus, derivatives, integrals. They describe what happens to a function as the input gets really close to a certain value. Let's find out right now. First, the formal definition. We write lim as x approaches a of f of x equals L. This means as x gets arbitrarily close to a from either side, without necessarily reaching a, f of x gets arbitrarily close to L. Important point. The limit doesn't care about the actual value of f at a. It might not even exist, or it could be something completely different. Simple example. Take f of x equals x plus 1. Then the limit as x approaches 2 of f of x equals 3. Plug in x equals 1.9, f of x equals 2.9, x equals 2.1, f of x equals 3.1. The closer x gets to 2, the closer f of x gets to 3. The limit as x approaches a of f of x equals L. The graph approaches the point a comma L, but there might be a hole, a removable discontinuity. For example, consider f of x equals x squared minus 1 divided by x minus 1. At x equals 1, the function is undefined, but the limit is 2. The graph looks like the straight line y equals x plus 1 with 1 point missing at 1 comma 2. When the limit is positive or negative infinity, we get a vertical asymptote. The curve gets closer and closer to the vertical line x equals a without ever touching it. Classic example, the limit as x approaches 0 of 1 over x squared equals positive infinity. The graph shoots up infinitely near the y-axis. As x approaches positive or negative infinity, if the limit is a finite L, we have a horizontal asymptote y equals L. The curve gradually flattens toward that horizontal line. Example. The limit as x approaches infinity of 1 over x equals 0. The graph hugs the x-axis more and more. Next, the different types of limits. Two-sided limit, lim as x approaches a of f of x, approaching from both sides. Left hand, lim as x approaches a from the left. Right hand, lim as x approaches a from the right. At infinity, lim as x approaches positive or negative infinity of f of x. Limits have super useful properties. If the limit of f of x equals L and the limit of g of x equals m, then the limit of f plus g equals L plus m. The limit of f times g equals L times m. The limit of f divided by g equals L divided by m, provided m is not 0, and also constant multiple powers roots, and so on. And don't forget the squeeze theorem, or sandwich theorem. If g of x is less than or equal to f of x is less than or equal to h of x near a, and the limit of g equals the limit of h equals L, then the limit of f equals L. Thanks for joining today, everyone. If anything's unclear, drop your questions. Happy to clarify. See you in the next session.